couple announcements. All right. Hello, everybody. So welcome to the first exam 2 review. So on this exam, remember we have enzymes, bacterial metabolism, then we have microbial growth and microbial or controlling microbial growth. And that includes the physical and chemical methods of control and antimicrobials. And let's see, I made this mind map today. So there's 1, 2, 3, 4, 5, 6, 7, 8, 10. If I could count, 12, 13. 13 antimicrobials that you need to know. In the content videos about it, I want to say I kept saying 11. There was some number I kept saying and it wasn't right, and I have no idea where it came from. But the only antimicrobials you need to know are the ones in the PowerPoint, okay? Like I was saying a few minutes ago, I think there's one in the videos where it's not in the PowerPoint, so you don't need to worry about that one. I can't think of the name of it off the top of my head. Okay, so we're going to go ahead and start with antimicrobials. This is the one that people tend to miss the most. Yes, thank you, Shelby. Yeah. With antimicrobials, there's going to be quite a few questions on the exam about them, okay? And so you want to make sure you know them. But a lot of people have a hard time remembering them and keeping them all straight. So I made a mind map. And I'm going to share my screen with it. Just give me 1 second. It's going to look like the screen is spazzing out as it does the sharing process. There we go. Now let me get my, so crazy how it does this. Here's the mind map. All right. Can everybody see that? Can you put yes or no in the chat if you can see it? Yes. Okay. Now I can't see the chat at the same time as having the Word document up, just because I haven't got my own office put together yet. So I've only got one screen. But if you have a question, feel free to come off of mute or put it in the chat, and I'm just going to have to go between screens, which is perfectly fine. All right, so let me make this about 100% so we can see the whole thing. All right, so this is just one way to kind of graphically illustrate the antimicrobials, okay? Because not everybody does well with lists, you know, things just bullets on a PowerPoint. And so this is one way that my brain works. Now, it looks like chaos, but bear with me. What's essentially going to happen is we're going to, in the circles, or I guess the ovals, we're going to put the name of the antimicrobial, specifically the antibiotics we're looking at. And then in the rectangle is where we're going to put the mechanism of action, which is basically how does it work, okay? So I chose a star in the middle. It ended up making my life really difficult trying to make this, but there are 5 different things that the antimicrobials are targeting in our conversation. And I color coded the 5. Okay, so up at the top, purple is translation. Going kind of clockwise, gray is metabolism. The blue is going to be the cell wall. Red will be plasma membrane. Green, nucleic acid synthesis. And I'm going to spell all this out as we go through it. But notice the purple has 2 shades of purple. And that's because for the drugs we're looking at, some target the large ribosomal subunit, and so that's going to be dark purple. The light purple are going to be the drugs that target the small subunit. So it's purple so that you remember translation, but I'm a visual person, and so I did 2 different shades of purple to remind myself that there are 2 different specific targets. Okay, I'm actually going to turn my video off. I have to move my computer screen close to me so that I can write and not look like a 2-year-old is doing it. So give me 1 second while I turn this camera off. Okay. All right, are there any questions before we begin? Do we kind of know what we're about to do?
I'm sorry, Chelsea, my internet cut out. Did you say there is a lecture with this or just the PowerPoint?
Yes, there is. They're posted, but it's not going to match the PowerPoint entirely because I make like a little flow chart of them rather than the bulleted list, but they're in the controlling microbial growth folder.
Okay, thank you.
Yeah, no problem. All right, so here we go. Let's go ahead and start at the bottom right in the blue. Okay, so here's where we are going to talk about the cell wall. So I'm going to write here what the overall target is. Okay, so blue is going to be, the target is the cell wall. So we have 3 antimicrobials that we need to know. Really, it's 3 categories. Okay, we technically have 4. So I'm going to scoot my computer close. Here we go. All right, so first up, we have those beta-lactams. Now remember, and I'm sorry, writing on a computer screen is really tough for me. This is going to be penicillin and cephalosporins. So I'm going to kind of abbreviate that. Penicillin and cephalosporins. And I'm just going to fill out the 3 drugs first. So we've got our beta-lactams. Then we're going to have vancomycin. And then we're going to have bacitracin. Now, if you've been studying your antimicrobials, as we go through this, try to fill it out on your own. Try not to look at your notes. Try to zoom me out a little bit if you can. Okay, so we've got our 3 antimicrobials that target the cell wall. Now, in the rectangles, you're going to put the mechanism of action. So take a few seconds and kind of make notes in the rectangle about how beta-lactams target the cell wall. How does vancomycin target the cell wall? All right, I'm going to start writing in the rectangles and then check yourself, and then I'll talk through it, okay? Now, I'm going to have to abbreviate just because on my computer screen it's not quite large enough. All right, first up are beta-lactams. So remember, y'all, bacterial cell wall. Okay, remember, peptidoglycan is a big component of the bacterial cell wall, and often there are multiple layers of peptidoglycan in the cell wall. And so in order to connect one row of peptidoglycan with another row, we do what's called cross-linking. Okay, so basically cross-linking is just going to be connecting one layer of peptidoglycan to another. Ooh, holy moly. Sounds like you're underwater. Oh, there we go. I wonder if it's because I was trying to write as I was typing. Maybe that's better. Okay. I knew something was happening when I heard the little buzzer. Okay. I'm going to try to not write while I talk. All right. So thanks, y'all. Let's see, get that back up. Okay. So for the beta-lactams, there's an enzyme that bacteria have that connect layers of peptidoglycan together. And what penicillins and cephalosporins do is they structurally resemble the substrate of that enzyme. And so they do what's called competitive inhibition. You'll learn that in the enzyme section. The drugs competitively inhibit the actual substrate. It prevents the enzyme from cross-linking layers of peptidoglycan. So the peptidoglycan of the cell wall isn't constructed. Okay, so they can't build the cell wall. So for vancomycin, so moving on to the next rectangle, the vancomycin is also targeting cross-linking, but it does so in a different way. When you look at the picture that's in the PowerPoints, you'll see those little tetrapeptides that are connected to the peptidoglycan, the little 5 circles that kind of hang down in little chains. Vancomycin specifically binds to those, and they kind of act like bumpers, And by binding those tetrapeptides, the enzyme cannot cross-link those layers of peptidoglycan. Okay, so I'm going to write that in the box so it doesn't mess up my sound. All right, so vancomycin binds those tetrapeptides, so the enzyme cannot connect them to one another. Okay, so it's preventing cross-linking. So again, it's preventing the cell wall from being made. So bacitracin is going to take a different approach. So remember, y'all, that the cell wall is outside the cell. So all the little pieces, all components that make up peptidoglycan, they are made inside the cell. They're delivered outside of the cell where the cell wall is built. So what bacitracin does, I remember this one because I think it gets back, EAC here. What bacitracin does is it blocks the little transport protein that allows the individual pieces of peptidoglycan from exiting the cell. So it's going to prevent those subunits, the components of the peptidoglycan, from exiting the cell. Because if the subunits can't leave the cell wall cannot be made. So kind of two different approaches here to preventing the bacteria from being able to make a cell wall. And without a cell wall, the bacteria are osmotically fragile. That means that they're going to lyse really easily. All right, any questions on the cell wall drugs? I'm going to try and make it so I can see the chat at the same time. Okay, I think that should work. All right, so let's keep on going because I want to make sure we have time to get through others today as well. Are these the antibiotics? So antimicrobial tends to be a generic term, just that kills microbes. You want to be careful with how you use the term. Can you hear me now? What is going on? Interesting. Okay. Yeah, just keep letting me know so that way I can repeat what I've said. Okay. So antimicrobials are a blanket term for things that kill bacteria. You want to be careful with how you use the term antibiotic. Antibiotics are specifically molecules that are naturally produced by living things that can kill other living things. So penicillin is naturally produced by a fungus. So we can say that it's an antibiotic, okay? Some drugs are made synthetically in the lab, so we wouldn't call them an antibiotic. But when you just say antimicrobial, you're kind of covering the whole spectrum. Does that make sense, Taylor? So it's more you have to be careful about saying antibiotic. All right, awesome. All right, so we're going to move. So moving on to the red. And for this one, this is where the target's going to be plasma membrane. I'm going to put right here, PM for plasma membrane. Ay, gee, flawless. This is driving me bonkers. Okay. I'm not even moving. I've stopped moving in general. I wonder if this is a Blackboard issue. Okay, here's what I'm going to do. I don't know if y'all can hear me. Okay, I'm going to stop recording. I'm going to exit the room and come back in and see if that